Hey, it's John at Tinderbox Arts. So today I want to talk about wheel sensors or ABS sensors. And this particular bike here is an R1200 RT, a BMW. But what I'm going to talk about also applies to other bikes. Here's a Triumph Tiger. And the wheel sensors or ABS sensors basically tell a computer what position a wheel is in, whether it's moving or not, and they are used for a variety of purposes. One is ABS brakes, another is the traction control that you see on some bikes, another is the speedometer. So it has multiple functions. Back here on the BMW R1200 RT, the front wheel sensor is right here, okay, and that wheel is associated with it right here. Now the back sensor on an R1200 RT and a GS and similar bikes that has a final drive is a little bit different. So on a bike like this that has a final drive, in other words, it doesn't have a chain, it has this final drive here, which transmits with a drive shaft, the power from the engine to the rear end here. You have a little bit different setup. Now here on the BMW, I'm going to go to the other side of the wheel and show you where it is, but just to get you oriented, here's the brake caliper, right? And right underneath here on the other side, I'm going to show you where the sensor is. It actually goes into the final drive, and inside here is what looks like a gear ring, but it's a special type of ring. That sensor is very close, almost to touching, and that gap is very important. We're going to talk about that. All right, here on the other side, let me try to get in here now. I have a pencil I'm going to point. So I'm going to turn the wheel a little bit, and if you look at my pencil here, actually that's not a good angle. Let me try another one here. Here's a good angle. If you look at the tip of the pencil, I'm pointing right now to the wheel sensor. So it goes in, there's just a single bolt here, that's where I'm pointing right now, and it goes into the final drive. One of the things that's really critical to understand about all these sensors in general is that spacing, physical spacing between the tip of the sensor and the wheel that it's measuring against is really important. Now in the automotive world, it's well known that these wheel sensors tend to go bad when all the salt on the roads and it just starts getting everything rusty. And it can actually lift up, the rust can actually lift up the sensor enough to cause it not to work anymore. All right, I'm back on the front wheel now. This is the RT. And so here's the sensor right here, the one end of it. The business end of it is right here. And you see it's pointing to this wheel, which has, spaces, uniform spaces in it. As the wheel turns, and now this is connected to your disc brake, by the way. So as this turns, the magnetic pickup on this thing is sensing the gaps. So what's important to understand in this kind of setup, which is very, very common, is that if there's any damage to this wheel, so let's just say it got bent or one of these, little gaps right here is missing or changed, it's going to affect what that sensor picks up. So you need to make sure that the gap between the tip of the sensor and this wheel is correct. And this wheel cannot be bent at all, because if it's bent, it's going to start moving in and out, and that's going to affect the reading. So very often actually, when you have a fault with the ABS or with the wheel sensor, it's related to physical damage. So either the corrosion that we talked about, in this case you have aluminum right here, but if that starts getting corroded, even though this is bolted here, it can start moving back and forth. Or if you take it out and put it back in, you may have buggered something up, got some dirt in there or whatever, you can cause an issue there. So this gap is really important. I'm going to measure that next and give it to you on this bike. It can vary though, depending on the bike. All right, when I measured this gap here, I got 1.2 millimeters. So that may be published somewhere, I'm not even really sure, but I know this is a working unit, so that just gives you some reference. Again, yours might be different, but there's a reference point for you. All right, so getting back to the testing idea, now that we know where it is and a rough idea of how it works, which we're going to talk about some more here shortly, electrically speaking, You know, how do these things go bad? Well, like I said, a mechanical or a physical problem is, I think, most common, and you're going to look for bent wheels or corrosion, and we just talked about that. But what about electrical problems? And that can also happen. So this is where we have to kind of talk in depth about electrical issues. There are two different types of these sensors. The old school type, which in the automotive world started changing around the 2000s, early 2000s, I think. Motorcycles may have lagged behind that, but the old school style of these things were a passive sensor, meaning that it basically just had a magnet and a coil, and as the wheel, whatever the wheel is, as the wheel passed by this magnet, it would induce an electrical charge, and that signal got sent back to the computer, but it was passive. And you could test those fairly easily because you could disconnect the sensor. There would be two wires on these old school ones, and you could connect a meter to those wires, you know, one lead on each side, and then turn your meter to the AC voltage, and you could turn the wheel, spin the wheel like this, and that magnet would induce a voltage, and you could measure it on the AC scale. That's the old school style. The new school, which is more common the newer you get, and this R1200RT is a 2012 model year, and it has a newer style. They are active sensors, and that means that it has a reference voltage sent to it by the computer, which is related to battery voltage, and then the computer measures against that reference voltage, you know, the differences that it sees when that sensor, you know, the wheel passes by the sensor. So it's a more accurate system, but it makes testing more difficult because really the only true way to test this, you know, to get an accurate reading is to put it on a scanner, or an automotive scanner, I should say, or an oscilloscope, you know, like a lab oscilloscope. And if you do that and you hook that up, you would be able to turn this wheel and you would see a square wave format on the scope. And if that square wave, you know, varied in any way, you'll be able to see that, and you'll be able to really hone in on a diagnosis easily. But most of us don't have a scope in the shop. So how can we possibly test this thing? Well, I've been doing some work in the shop for about an hour here, trying to get an idea of how we might do this just with common tools that we have. So I'm talking about a multimeter or, you know, something really simple like that. It's not going to give us an accurate diagnosis as a scope would, but it'll give us some idea whether everything's working. Now, I should also mention that these sensors tend to have an integrated, well, they always have an integrated harness or wire associated with it. So it's not easy to get right down close to the sensor and probe those wires because they're usually encased in some kind of insulation to protect them. So what we need to do is find the nearest connector to the harness. Now, in this R1200RT, I traced it back. So I followed the sensor, followed the wire back, and on the right-hand side of the bike, not taped, but wire tied to the frame, was this connector. I have some probes in here now, but it was this connector, and then the other side of it is right here. All right, so it was kind of tucked down right in here. Now, your bike may be different. On the front, I believe the sensor connector is tucked underneath the fairing here. I didn't actually look for that one. But all of what I'm about to tell you applies to all these sensors. You just have to find the right connector. So I found this connector, I disconnected it, and I confirmed that it was an active sensor. So you're gonna see a voltage signal when I turn the bike on. All right, now what I can do here, I have connected, this is really tenuous. I can barely reach the key, but I have connected now with these alligator clips. I have it reconnected through the alligator clips as if it was connected like it should be. So the rear sensor is connected to the computer right now. I have my meter probes here. All right, I'm gonna, oh God, I gotta reach over here. I'm gonna reach over, turn the bike to the on position, all right? So that's on position, but not started. Now if I put this is a voltmeter on the DC volt scale, right? And I'm just gonna carefully touch these pins, I hope. And I get 11.29 volts, okay? So I gotta be careful not to touch those pins together. So I just want you to understand, that's what that reference voltage is. That reference voltage probably would come up to 12 volts once I turn the bike on, which I'm not gonna do now because I don't want the vibration to screw all this up. But just so you understand, that's one test you can do, is to turn the key on and you should see that reference voltage come up from the harness side. So that's what I just did. The reason I kept everything connected was just so I don't get an error message. Now I should mention, if you have the GS911 tool, you can get readouts of fault codes that are stored, and that may also help you. So if you have this, obviously you want to use it. All right, let me introduce you to my little test rig here. So we don't have a scope, and actually I have a meter, a handheld meter that has a scope function that I just very recently purchased. It's not even here yet. I was kind of hoping it would come for this video, but I may not have it in time. So anyway, instead we're going to use this test rig. So this is something I made up on my own, obviously. It's very simple to make though. All you need is an LED bulb, okay? And really almost any LED will do, but a small one. You don't need anything big. You don't need like a headlight bulb or anything like that, just something very small. And then I soldered a lead for negative and positive on either side. So this red tape you see here is just insulation. So you have a negative and a positive lead. And then I also have, actually, before I move on, remember that LED lights do need the right polarity. So if you have negative and positive mixed up, this will not light. So just make sure you have those marked. I marked positive with a red tape here so I know. And then the other thing I've added here is a resistor. So the point of this resistor is really just to cut down on the amount of current going through there so that this bulb isn't quite as bright as it would be otherwise. Because what we're going to do here is, you remember these active sensors need a voltage in order to do their job. So we're going to introduce a voltage through the circuit, and I'm going to put this test light in the middle of that circuit. And when I spin that wheel, if everything's working right, I should see this light blink. Now it's a crude, it's not going to tell me if the signal is perfect. There could still be things wrong, but it's a crude way of figuring out, is there any signal at all coming from that sensor? Now you see a battery here too, right? The battery, the 12-volt battery in the bike could certainly be used to turn this LED light on, and it would certainly go through the circuit for the sensor. However, I'm going to be using, alligator clips and, all sorts of wires hanging everywhere in order to connect all this. And I'd rather not introduce the 12-volt battery with a lot of juice behind it, where I might do a short and, cause the sensor itself to cook or a wire to cook or whatever. All right, so this is my test setup. Remember, here's our connector for the ABS sensor, the wheel sensor. And I have two alligator clips in there. It's a little, it's a little dicey, I'll admit. I have a piece of paper in there just to insulate the two alligator clips. And you got to make sure that those are touching. It can be a little tricky, so pay attention there. And then at the other end of those alligator clips, I just have one side going to my test light right here, and the battery, the 9-volt battery, is hooked up, and I did use the resistor. I'm not sure if that comes through on camera, but that LED light is lit. Like, I can see that in real life. I think on the camera it may not come through. The fact that now I've connected all this and that light is lit tells you something, right? It tells you that there is continuity between all the cables to the sensor. So we know that the light is lit up. That means that the wires themselves must be good, because that light would not light at all if the wires were bad. So if you have crimped a wire somewhere or clipped it or something and you're worried about it, well, if this lights up, that tells you now that the wire is actually okay. The next question then is, if I spin the wheel, will we see this thing blink? Now I'm going to see if I can reach down and do this at the same time. right, so I'm spinning the wheel right now, and that is not blinking. So that's telling me there's a problem in the sensor. Now I'll tell you what, I'll hook this up just for the sake of argument. I'm going to put this on the other side of the resistor. That's a little bit brighter maybe. So you can see it is lit up, but again, I'm spinning the wheel and I got nothing. All right, I took off the tire or wheel just so I'll give you a better look in here. And so right here is the rear sensor on this bike. So there's just a Torx nut there. I take that out and then this sensor will pop out. I just have to get the cable kind of unwound from the bike there. So I'll work on that for a few minutes and then we'll put the new one in and give that one a test. All right, I got my little test rig set up here for the new sensor, and I actually learned something here. Boy, you got to watch yourself. So I've used this test rig or one like it on automotive style wheel sensors, and most, or I think all of the wheel sensors I've tried it on the automotive world were not sensitive to polarity, okay? So in other words, it didn't matter which way you set up the positive and negative. As far as the sensor, the bulb, yes, but as far as the sensor, no. However, having just tried it here, I've come to figure out that this particular sensor anyway, it does matter. So if you don't get the right reading immediately, reverse the polarity, okay? Reverse the polarity for the sensor, and you may see it blink. So I hope this comes out on camera. So I'm going to attach this. There's my light. Now, I'm not sure if this blinking is going to come through, but I'm going to turn the brake now. Yeah, I think that's coming through. So you can see there, it's blinking. That tells me that's a good sensor. It tells me in two ways. Number one, I have continuity for the circuit, so I know the wires are good. And number two, I'm getting a blinking signal, which tells me it's picking up the, sensor is picking up the tone wheel and giving me the signal that I need for the computer. But I want to emphasize one more time, if I reverse these two leads right now, then I would get a solid light, but nothing else. So that's why I'm saying pay attention, test it both ways before you give up on a sensor. But it does work. So this is a pretty good way of testing, inexpensively. These LED lights are peanuts to buy. You don't really need the resistor, but if you want to put one on, you can. And it's a good, it's crude, but it gives you a way of testing it. Now here in the front, as I said, it's actually easier access. So same procedure, nothing changes. It's exactly the same. As a matter of fact, this sensor is the same front and back, and from what I can tell, this sensor is widely used in a lot of BMW bikes. They don't even change the length of the cable or anything. So if you have a GS, probably the identical one, and even some of the other F bikes and K bikes I think are also identical. So this little thing that I showed you today will work for a wide variety of different bikes. So just make sure you button up everything nice as far as tying it off and make sure that cable doesn't bounce around. But what we've learned basically is that you can use that little test light kit for two purposes. One, to make sure the wires to the sensor are okay, because if it lights at all, then those wires are okay. And the second thing is, if it blinks, you know you're getting a signal from the sensor. And I learned something today, because in the past I thought all those sensors were not polarity sensitive, but we learned today that they are. So if you get a solid light and you're spinning the wheel, switch the polarity on the sensor and then see if you get a blinking light then. If you do, there's some kind of signal there. It may not be a great signal, there may still be issues, but at least you know you're getting something. So that's about as far as you can go testing with that little light. And the next best thing would be, or the better thing would be, to get a scope, and then you could actually see a picture of the signal to make sure it's good.